Welcome back. This is 2.2, one and two-step equations. So as far as I can tell from most of you guys, you've done this before, and there's nothing new here. This is just a good review. We'll be doing that a lot with more complex equations and things like that, but we'll get started with the basics. So one and two-step equations. All right, so there's some good rules. When you're solving an equation, your goal is to get the variable alone on one side, okay, and this is called, we're trying to isolate the variable, okay. When we're solving for variables, we must use inverse operations. So that's what we do when we say we add something to both sides, or we subtract something from both sides, or we divide on both sides, or something like that, okay. Those are the inverse operations. And then the last thing is, which is basically the same thing, is whatever you do on one side of an equation, you must do it to the other side. Okay, it's just like when you're lifting weights, you have to add or subtract weights to one side of your barbell, okay, so that it's all evened. All right, so let's just do some examples. All right, so when you do these types of problems, you may want to think, how can I isolate this variable? How can I do it put it by itself? What operations can you use to solve this equation? All right, so let's just go over some of these. Like I said, I think you guys probably feel comfortable with this from previous years. Okay, so here we want to get x by itself. How can we get rid of that 2? Well, since they're being multiplied, we're going to do the inverse, which is division. So we will divide both sides by 2. So we'll get x, the 2's will cancel, and we'll end up getting 8. Okay, if you wanted to double check, like here it says you can always check, see if your answer's by substituting it back. So if we wanted to check, this one's pretty easy to check. You just plug it back in, 2 times 8, and that should give us 16. And it sure does. Okay, so it would be good to go. I think it's a really good idea to double check your answers, especially on tests. All right, here they're being subtracted, so the opposite of subtracting would be adding. So we will add 7 to both sides, and we'd get a equals 11. C, so please pause if you can. Pause and see if you can do the rest on this page. Okay, I'll go ahead though, since it's negative, it's subtracting 5, so we're going to add 5 to both sides. That would cancel, and all we'd have would be D equals 3. Okay, these are pretty simple, so hopefully you feel like you're good. Here they're being multiplied, 5 times R, so we'll divide it by 5. And we'd get R equals 9. E, since it's adding, we have F, we want to get F by itself, but it's adding 5 to it, so to get rid of that we would subtract 15. Did I say 5? I meant 15. So that would end up giving us F equals 22. All right, and F about the same, so we would add 91 to both sides. We'd get K equals 94. All right, so next page, again, we're going to use the inverse properties. So here x is being divided, so the opposite of dividing is multiplication, so we would add 5 to both sides. We'd get x equals 450. D, again, it's being divided, so to undo a division, we multiply. Get W equals, I think it's -1, 28. Would be -196. And again, we would multiply it by 64. k equals 19 times 64, which is 1,216. All right. Same thing, we're doing decimals. The same thing as you would do if it was a whole number, okay? You can do this by hand. I would suggest probably doing it by using a calculator. But here these are being multiplied, so we will divide, use its inverse. We have to do it to both sides. All right, and that ends up giving us x equals, I think it was 5.7. Double check. Yep, 5.7. Okay, this is also decimal. Since they're being added, now we're going to subtract. So we get h by itself. H equals, that would cancel. We get h equals 32.7 minus 8.6 gives us 24.1. And then C, same thing, we would add 6.5. We get x equals 35.6 plus 6.5, which gives us 42.1. Okay. One thing I would also suggest is if we're ever using decimals, keep your answer as decimals. Okay. I think a couple of you guys on the test, since the calculator automatically, at least some of the calculators automatically put it in a fraction, you wrote it in as a fraction. Please, if you're using decimals, have your answer be decimals. Okay. All right. In Unit 1, we learned how to use order of operations, okay, to simplify expressions. When solving equations, we use the inverse operations to undo the operations using the opposite sequence. So, for example, what I'm trying to say is, in the past, we used PEMDAS. We'd start with parentheses, then we'd do exponents, and then we would do multiplication, division. Remember, these are always a pair. So if I did a problem that was like 4 divided by 2 times 5, we would need to do division first because it comes first, okay? And then we would multiply. I think sometimes people get confused thinking that since we write it in PEMDAS, multiplication goes first. Oftentimes people will try and do all the multiplication first. But since it's like a pair, okay, you need to do both of them just in order of left to right. So if division comes first, then we'll do division first. If multiplication comes first, then we'll do multiplication. Okay? But when we are solving, we will go backwards. We will do the adding and subtracting first, and then we will do multiplication, then we'll do exponents if there are any, and then we would do parentheses. Okay? So let's do some examples of that. All right? So we want to get b by itself. Okay? And remember, if we're doing opposite of PEMDAS, we'd need to do adding and subtracting first. So here we would subtract 3 from both sides. That would give us 10b equals 30. Those would cancel. Okay, and then we've done our adding and subtracting. Now we'll do our multiplication division. So here we would subtract 10. We get b equals 3. Okay, and if you wanted to check, what we'd do is we would plug or substitute what b is equal to. That would give us 30 plus 3, and give us 33, which is the same as the right side. Okay, and that would verify that we had the right answer. Okay, next one. Okay, adding, subtracting. So this is a positive 8, so we need to subtract 8 to both sides. That would cancel. We'd get negative n equals 8. Okay, and again, if we don't have a number in front of a variable, we can always put in a 1. So we can divide both sides by negative 1. We get n equals a negative 8. All right, so pause and see if you can do these next 4. Okay, again, adding, subtracting first. So here we would add 14 to both sides. That would cancel. We get 19 equals x over 3. And then to get rid of the 3, since it's division, we're going to multiply, because that would be its inverse. And that would give us 57 equals x. Somebody also asked, is that the same as writing it like this? Okay, and you'd say for sure. I would always write what we're solving for, which is x, and then find what it's equal to. Okay, so just flip it around. All right, that would be kind of like standard. D, okay, want to get x by itself, so we'd do adding or subtracting first. We would add 50 to both sides. That gives us 3 equals 3x. Okay, and then to get x by itself, since this is multiplication, we would divide. That gives us 1, and that gives us 1, so we get 1 equals x, or better, x equals 1. All right, E. Okay, so here, adding and subtracting first. Well, we don't have any, so we'd go straight to multiplication and division. Okay, so here we're dividing by 5, so we could multiply by 5. Okay, whenever we do something like that, it's always going to cancel things out. Don't think you're going to multiply the 5 and the 2. That would not simplify what we need. Okay, so we have 2k equals 20. And then to get k by itself, we'll divide both sides by 2. Our k equals 10. All right, and then F. There's different ways you could do this. Most students that I've talked to, they choose to distribute first to give you 15 minus 3n equals 6. Okay, and then we'd subtract 15 to both sides. That would give us negative 3n equals negative 9. And then we would just divide both sides by negative 3. Okay, so n equals 3. All right, now let's do some word problems. So Brian and Zach went to Village Grill for lunch. Brian's lunch cost 4 less than 3 times Zach's. Okay, so so you may want to pause and see if you could try and figure out what we're writing down. Okay, so basically, let's say Zach, we'll call Zach's X, okay, his cost of his lunch. But we know that Brian's is 3 times Zach's, so 3 times X, less 4. Okay, so this is how much Brian's cost, and this is how much Zach's costs. And then they tell us the total cost is $24. So if we add Brian's and Zach's, we do 3x minus 4, and then we have plus x, which is Zach's. So here's Zach's. This is Brian's. Okay? And he says that the total cost is 24. And we just want to solve for each of theirs lunch. Okay? So, first thing I would solve for x, because Zach's lunch cost is x. So we'd combine like terms. These are like terms, so that would give us 4x minus 4 equals 24. And then we still want to get x by itself, so we could add 4 to both sides. That would give us 4x equals 28. And then we would divide both sides by 4. That would cancel, we'd get x equals 28 divided by 4 would be 7. Okay, so Zach's lunch costs $7. Okay, and now we want to know how much Brian's costs. Well, we know that Brian's, we have a little expression for the cost of Brian's. So for Brian, cost would be 3x minus 4. Well, we know that x is 7. That'll give us 21 minus 4, which is 17. So Brian's lunch is $17 and Zach's is 7. Okay? So that's kind of a bigger word problem, but take some time to think about it and see what you can come up with, if that makes sense. Okay, next we have you collected $345 for class t-shirts. The company you're ordering the t-shirts from charges $5 per t-shirt with a one-time setup fee of $30. Okay? So we have the total cost, $345, okay? And part of that has to be the setup fee, which is $30. And then the rest of the money is going to be for the t-shirts. And they said that they're $5 a t-shirt. So we'll call the number of t-shirts be X. Okay? And how many t-shirts can we afford? So all we're going to do is solve. This would be a two-step equation. So we'd first subtract 30 from both sides. We'd get 315 equals 5x. And then to get x by itself, we would divide both sides by 5. Okay, that would cancel. We'd get x equals, I think it's 63. Okay, 63 t-shirts is the most that they could buy. Okay, all right, well, sounds good. If you have any questions, let me know, please.